LEDs. LED is an acronym that stands for light-emitting diode, which is just a specialization of a diode, which is, for the most part, a very brilliant but deviously simple electronic component that allows current to flow freely, for the most part, in one direction and blocks it in the other, a one-way valve. There's, of course, special types of diodes, and of course there's their next evolution, the transistor. You should have heard of that one. But that is a lot of videos that are not this one. So let's just stick to LEDs. First of all, an LED has a positive and negative terminal. As we said, current is designed to flow in only one direction. If you try to make it flow in the other direction, so don't do that. Generally, you're going to find the negative terminal. There's a little flat part, so you've got the bulb of the LED, and then you've got this little lip, this little rim around it. There's a flat part. That part is usually next to the negative leg. Or, on a lot of them, if they haven't been cut, you will find that there is one leg that is longer than the other one. That is the positive leg. So find a flat spot, that's where your negative leg is. Find a longer leg, that is your positive leg. Or you can test it. So we'll turn on a power supply. Remember to always check that your amps are zero. In this case, my volts are zero also, as we can see. So the way you want to check an LED, if you're not sure which way it goes, is you want to apply a minimal amount of power, because in the reverse direction, it's going to block it and it's not going to work. In the positive direction, it will. A little bit of power applied in reverse will do no harm to the LED, or to any diode, in fact. So you just have to keep the power low. But I'm going to go ahead and plug it in correctly the first time, just to show you. And of course, this is technically a short circuit, but remember we have a current limiting power supply. So the problem with a short circuit is runaway current. We can't have that here, so we're fine. So first, I'm going to set my voltage to a common 5 volts. This is a good voltage to use because it's USB power. And USB power is very common. Arduinos use it. It's nice and ready. Every computer has it. You've got all these chargers you can plug in, phone chargers. So it's quite common. 3.3 volts is also common. 12 volts is also common. But 5 volts is super common in computer electronics. So, of course, nothing's happening to the LED. So I'm going to turn it to a minimal 1 milliamp. You can actually turn it to less than this, much less than this, in fact. If you have, of course, a more expensive power supply, mine only does this, it's perfectly fine. So just 1 single milliamp. And you will see, oh, I keep forgetting this breadboard is a Frankenstein's monstrosity. This part in the middle, these two power traces, are actually separate power traces. If you ever get a giant breadboard like this, be sure to test it and figure that out. But in this case, all I have to do is move it up here, and it will work fine. Let's try that again. 1 milliamp, and you'll see that it came on. Now, I hope I got my hand out of the way in time. In fact, let me move this so that you can see better. So let's try that again while you can see what's happening to the LED. So watch the voltage output. See it goes up, and see the LED slowly lit. And it's at 1.76 volts. So here's the thing. LEDs are what are called non-ohmic devices. That means this doesn't work. So what you have to do is figure out, so usually, of course, you have a spec sheet. When you buy your LEDs, it gives you info about using them. This is for when you don't have that, or you just don't care, because it's really not necessary. The spec sheet is more of a guideline. So the way a diode works is, in reverse, it doesn't let current flow, don't worry about it. When you're using it correctly, there is what's called a forward voltage drop that's based on the current. The more current, the more the forward voltage drops until you get too high and stuff starts to break down. Within the normal operating range, then you have a forward voltage drop proportional to the amount of current you're pushing through it, at the voltage, of course. So, for example, if your forward voltage drop is 3 and your power supply is 5, then you're going to have 2 volts left over. So that, of course, is going to overload your LED. So what you do is you put a resistor. A common thing is just LED plus resistor, and that's it. So your resistor brings the voltage down using Ohm's law outside the LED to get the LED to the right voltage so that the current is flowing through. For example, if your forward voltage drop was 3 and your power supply was 5, then you can find out your voltage is going to be 2 because it's left over, right? Because you've got 5 volts from your power supply, and then you've got to balance that 5 volts. 5 volts in, 5 volts out. If your forward voltage drop is 3, then you're going to have 2 left over you have to do something with. So what you do is you have your, as we're going to demonstrate, what you do is you have your 5 volts, and you figure out what milliamps you want. That's going to be your current, all right? So actually, we're going to use this one. So we're trying to find out the resistor value. So your voltage drop that you want is going to be 2. 5 volts from your power supply, 3 you're taken care of by the diode, and then 2 left over. And then you have the current, that whatever your power supply put out, and then you just divide it and you get the resistor value you need. And then, of course, resistors are not exact. You just pick the closest one, you'll be fine. And different colors also have different current requirements. Certain colors require more power to make the color, but we're not going to worry about that. So once again, I turned it up to 1 milliamp, and it goes up to 1.76 or so volts immediately, just to turn it on. But watch this. If I turn it up to 2, it only went up to 1.84. Look, it's only going up tiny, tiny bits now. See that? 3, 5, 8. It's barely going up at all per millivolt now. I mean, per milliamp now. The reason for that, and let me turn that down before we blow the thing up. We're not going to blow the thing up, it's just too bright. But the reason for that is the forward voltage drop. The initial amount to overcome the internal mechanics of the LED, and then over that is how much you're actually putting in there. So now, to demonstrate that we can check to see which pin is the positive and negative, which way you should plug it in, I'm going to put it in backwards. Remembering this breadboard requires me to put it where that is. So I'm going to turn it up to 1 milliamp and then turn it right back down. Watch this. 1 and back down. And you'll see nothing happened. Let's try again. Turn it up to 1. It's going up and up and up and up, and turn it back down. See, it went over 3 volts, which is double what we had the other way. Nothing was happening. What happens is it reached what's called the breakdown voltage, which means the LED is no longer blocking and the LED is breaking. Let's confirm to see if indeed I broke it. And the LED is fine. But if you left it in there, the LED would not be fine. So as long as you do very low amperage and you're very quick to test, just turn it up, see what it goes to, turn it down. Or if you're using some other device, use a variable resistor just to see which way it turns on. So now I'm going to demonstrate how you actually use this thing in a circuit. So I'm going to put it over here into this trace. And as I said, the circuit is usually a resistor and an LED connected to your power supply. And you just calculate the resistor to be the right value. So I'm going to connect the positive of the power to the positive of the LED. The order of the resistor and the LED does not matter. That's one of the magic things about electricity, because there's an electric field that is established by all the parts, and then current moves because of the electric field. Things in different orders actually do the same thing. Not always, most of the time. As long as you're not dealing with complex parts like integrated circuits. If you're just dealing with diodes and resistors and such, the order actually doesn't matter. And that's freaky, but there you go. So I connected the positive of the power to the positive of the LED. The negative of the LED to a 10,000 ohm resistor, 10k ohm, which is just my favorite type of resistor. I can't explain why, it just kind of is. It's a very handy number. You start dealing with microamps and you can't screw up. And then we connect the negative of the resistor. Make sure that's in the right spot, and it's not. Let's put it in the right spot. There we go. To the negative of the power, which of course will do nothing. Now, here's the fun part. Now I'm going to turn it back up to that 1 milliamp. Watch the LED closely. And it goes all the way up to 5 volts. You'll notice it's much dimmer now, and it's reading 0 milliamps. That's just rounding. It's less than 1 milliamp. So what happened was I told it no more than 1 milliamp. So it turns up the voltage, up, until it reaches 5 volts, and then it says, okay, well, he wants 5 volts, so now we're going to stop turning up the amps. The milliamps here is the limit, no higher than. So once we reach the voltage, then there you go. Before, it was reading 1 milliamp because it reached something less than my voltage limit. And then it was like, okay, no more current. We're going to stop this voltage here. And you'll notice it came on very slowly because this was very slowly turning the voltage up, and now it's dimmer. Because we have this resistor in there, which, as we said, the LED is not ohmic, but the resistor next to it is, and that determines how much current is going through. So it's a multi-step process, but it's easy. So you've got your power supply voltage. That's it. So then you have your resistor and your LED, and they will equilibrate. You have a certain amount of current going through that, right? The resistor decides how much voltage that is, and then the current at that voltage decides how bright the LED is and what its forward voltage drop is. If you really want to figure this out mathematically, you start studying Kirchhoff, you start studying Maxwell, and you go to college. But this is why we use a nice bench power supply. This is not even $100. I think it was $60. I'm pretty sure it wasn't $80. I don't know how much it was, but it was this little cheapy power supply. You can also do it with just a regular power supply and a variable resistor, potentiometer. It's just a dial that you can turn the resistance up and down. You can do that too. That's another way to do it. It's you can also use what's called a trim pot. A trim pot is just a dial resistor, but it's meant to just stay in there. So you use a little screwdriver to turn it. So if you don't want to do it this way, you can get yourself a variable resistor, stick it in with the LED, turn on the power, turn the resistor until it's the brightness you want, and then just leave it there. It's not economical if you're making a commercial product, but if all you're doing is this, well, there you go. You have your resistor, and you don't even need one of these. But this is great because you might have a pack of 10 of these things or whatever, and you just want to throw it in there, and you might want different brightnesses. So you can just write down a number like, oh, if I use these LEDs, put in a 4.7 k ohm resistor or whatever. You know, well, it's not going to be k ohms, but still. You can just say, if I use the red ones, put in this resistor. If I use the yellow ones, put in this resistor. You just have a little sheet of paper with that written on it. So if I turn the amperage up, of course, nothing's going to happen. Oop, pardon me. I turned it down. So now I'm actually going to turn the current limit up just so I can demonstrate. Now I'm going to turn the voltage up. 6, 7, 8. You see how it's getting brighter? This thing is rated for, I believe the sheet I had was something like 2 to 2.5. Most of your LEDs are going to be anywhere from 2 to 3.5, depending. But the resistor is, of course, dropping the current. So as we can see, this is at 9 volts. The resistor is 10 k ohms, which is a very big resistor. And we are still reading with a limit of 22 milliamps. We're still reading 0, which means it's still less than 1 milliamp going through this. Now, the resistor might be heating up. Let's see. A little bit. The resistor, because it's a high resistor, is dumping a lot of the power as heat. This is incredibly wasteful. You should actually be using something like a 300-some ohm rather than a 10,000. But let's keep turning the voltage up a little bit. See how bright it gets. Oh, we're up to 2 milliamps. Up to 15 volts. This is why you don't use a 10 k ohm resistor. But in any case, let me set this back at 5 volts. And now I'm going to show you how to actually use this LED. So put the LED back up in here in the correct place, please. So now we're at the point you want to make your circuit. So you're going to say, okay, I know about how bright I want this. I know what power supply I have. What amps do I want? So it's easy. So we're going to say we want 5 volts, 1 milliamp, and that goes up to 1.76 volts, right? So let's say I want it how bright? Let's say I want it that bright. So we're going to say we want a current of 0.003 amps, of 3 milliamps. We have a forward voltage drop of 1.84. Right? That's how much voltage we're putting into it. So the leftover is going to be 5 minus that. So to figure out your resistor, so you're going to take your input voltage, 5, all right? And you're going to do minus 1.84, which is how much is actually going through this LED right now. So 5 minus 1.84 is this, V. Your current is 0.003. 3 milliamps is 0.003 amps. So 5 minus 1.84 quantity divided by 0.003 is going to give you in ohms what resistor you should use. And I have now calculated this out. 5 minus 1.84 is 3.16. Divide out your 0.003 and you get 1,053 and a third ohms. So 1K ohms. Much less than I'm using there. So let's get a resistor that's fairly close to that. And let's also turn off my power. So I have here a 1,000 ohm resistor. And I hate reading the little codes, the little color codes. So I just have this nice set where it's written on the bag, and I keep them in the bag. And then if I ever drop them and I have to sort them again, I cry. But it's not that hard, it's just annoying. So I'm going to put this over here. This 1,000 ohm resistor. So put that leg in there and that leg in there. These thin-legged resistors are annoying in breadboards, but that's all right. And then I will put this over here to the separate trace. So now we go from our positive power supply to the positive end of the LED, the negative end of the LED, which is over here, the negative end of the LED to one end of the resistor, it matters not. The other end of the resistor, you can put it before or after the LED, whichever suits your particular needs, desires, tastes, to the negative of the power. Now we're using our full voltage, 5 volts. So now I'm going to turn it up to 0.1, 3, and you'll see if I turn it higher, it stops at about 0.6. This is close enough because, again, nothing's perfect. The actual calculation was 1,053 and a third ohms. That was, first of all, the 0.003 here was rounded. I could have used my multimeter to get a more exact number. And the 5 volts, there's a little fluctuation. There's a little fluctuation in all of this. There's extra resistance from the wires, or there's less, or there's more. The tolerance on the resistor, this is 1,000 ohms. It could be 996. It could be 1,012. It could be any of that. Nothing in electronics is perfect. You've got to work within tolerances. And that looks just fine. If it's too bright, then go get the next one up. I have a 1.2K ohm resistor. Just stick that one in. Or use a trim pot if you want it to be exact. But then better make sure your power supply is exact or it's going to change. So that's the basic principle of using an LED. Let me go over the steps one more time real quick. Always turn your power supply to 0. You set your voltage to whatever power supply you're using. You turn up your amps until it's about how bright you want. You take the volts and amps. So you've got your 5 volts power supply minus the amount that the LED is using. And that's your V. Your current is your I, divide it out. There's your R. Pick the nearest one. Make it a little more, a little less, depending. And there's your circuit. You go from power supply to LED to resistor, back to power supply, or power supply to resistor to LED, back to power supply. And remember, if you're using the power supply to test, which way you plug the LED in, remember to use the minimum voltage possible. 5 volts is a good one because all common LEDs are going to be under that number. And just turn it on real quick. If your voltage starts climbing really high and it's not turning on, turn it back off real quick. A few seconds ain't going to hurt it. And then turn it around. It should come on immediately. And then just mark down which way is correct. Turn your power supply to 0. And you're done. This is a great way to do it if you don't have a spec sheet or you just don't care. But most importantly, for someone like me who just collects random electronics and likes to cannibalize them for parts, not for an economic reason, because obviously it's more economical to buy new parts in bulk and you get a nice discount, and you lose money on the tools and time to do the cannibalism, especially if you damage them, and especially if you have to pay for the spare parts. But if you just come across old electronics, or you're just having fun, because disassembling electronics is also a learning experience. So if you're using found parts, as you might call them, then this is a great way. You don't have to worry about spec sheets. You don't have to worry about anything. So when you're digging through the rubbish bin and you find random LEDs scattered about, now you know how to use them. So have fun. I'll be seeing you.